You're tuned in to Beyond the Known. In 1984, a secretive CIA remote viewing experiment took an unexpected turn. The target, Mars. The viewer described tall, thin beings, ancient pyramids, and a planet devastated by catastrophe. Was it a psychic glimpse into an alien world or a buried memory of our own origins? What if Mars isn't just a planet we're curious about, but a place we once called home? In this episode, we set course for the red planet, where myth, science, and mystery collide. And that collision is precisely what we're diving into today, Mars, the red planet. It has held, well, such a unique place in the human imagination for millennia, hasn't it? A source of deep mystery, fascination, stretching way back as far as we've looked up at the night sky, really.
Oh, absolutely. You think about the earliest civilizations, the ancient Egyptians, the Babylonians, the Greeks. Our research shows they all tracked Mars's movements very keenly.
And that red color must have really stood out.
It absolutely did. That striking color set it apart, earned it a pretty significant role in their mythologies, their understanding of the cosmos. And even, Galileo, with his first telescopes, he just added to the mystery, seeing features that hinted at, well, something more than just a point of light.
And that early fascination, it didn't just fade away. It evolved dramatically with modern science, with space exploration. We went from wondering about canals built by Martians to actually sending robots there.
Right. Probes, rovers.
And what that modern scientific pursuit has uncovered is, well, it's nothing short of incredible. The evidence we have now strongly suggests Mars was once a world vastly fundamentally different from the cold, dry planet we see today.
Exactly. And that difference, that transformation, that's where the real mystery starts to deepen, I think. If it was so different back then, what happened? What could possibly change a whole planet so drastically?
And could that past, the possibility of life, maybe even connections back to Earth, could any of that align with the scientific picture that's now emerging?
That's the core of it. Our mission in this episode is really to explore that space where, the hard scientific findings meet our long history of human curiosity and, some of the more unconventional, debated ideas about Mars's past.
So we'll be pulling together insights from our research, looking at scientific reports, historical accounts, and examining these different theoretical perspectives, trying to see Mars through multiple lenses, essentially.
So what secrets are locked away up there about its deep past, its potential for life, maybe even echoes relating back to our own origins here on Earth?
Especially now, as we're seriously talking about sending humans there. Are we just, discovering a new world? Or is there maybe, just maybe, a deeper connection we haven't quite grasped yet?
Could we be discovering something or maybe remembering something?
Are we really just Earthlings? Or is there something about our past that makes us, in some way, Martians in exile? That's the big, compelling question we're getting into in this episode.
Okay, so let's start by setting the stage properly. Really appreciating just how deep this connection, this fascination with Mars, goes in the human psyche.
You really do see it immediately when you look up, don't you? That color.
Mm-hmm. That distinct red hue. Our research confirms this is what grabbed the attention of ancient astronomers all over the world. It wasn't just another star. It had this unique look that, well, it demanded attention, demanded interpretation.
And in so many cultures, that color-blood fire led to associations with, well, conflict, power, gods of war, destruction.
Right. While our research doesn't dig into every specific myth, the pattern is clear. Mars consistently played a significant role in ancient thought, marked by that unique appearance. It stood out, and people gave it meaning, powerful meaning.
And that didn't just vanish with ancient times. That visual power ensured it stayed lodged in our culture. As astronomy got better and then science fiction just exploded, Mars became this kind of blank slate for all our hopes, our fears, our biggest fantasies.
Oh, definitely. Think about the late 19th, early 20th centuries, the whole canals of Mars thing.
Right, based on those telescopic views that turned out to be.
Optical illusions, yeah. But they fueled these incredible stories of advanced civilizations, maybe dying ones, desperately trying to survive on a drying planet.
And H.G. Wells took that fascination and flipped it into fear with War of the Worlds. Martians not as builders, but as invaders.
Exactly. And that really cemented Mars in the popular imagination, didn't it? This mysterious, possibly inhabited, somehow really significant world next door.
It absolutely fueled the dreams, not just of Martians coming here, but of us going there, visiting, maybe even living there someday.
And that blend ancient myth, those early observations, the sci-fi stories, It all ultimately pushed us towards wanting to actually explore it scientifically.
Precisely. Our research shows that this long, intense history of human curiosity about Mars was really the engine driving our modern space programs. We didn't just send probes out of, purely abstract scientific interest. We sent them because Mars was already so deeply embedded in our imagination as a place worth going, a place that might hold secrets.
It's a fascinating interplay, isn't it? Imagination asks the questions.
And science builds the rockets to find the answers, but often the answers science finds are even stranger, even more interesting than anything we could have dreamed up.
They really are. And it brings us right back to that fundamental question we started with. Could the scientific story of Mars's past, the one we're uncovering now, somehow link back to Earth's story?
Okay, let's pivot then. From myth and sci-fi to the hard evidence, the data sent back by our robotic explorers, that first close look we got from Mariner 4 back in 1965, it wasn't exactly encouraging for finding, bustling Martian cities.
No, it was a bit of a reality check, wasn't it? Our research highlights that Mariner 4 saw this heavily cratered surface look ancient, very arid.
And the atmosphere.
Very, very thin.
Mm-hmm.
It measured incredibly low atmospheric pressure, something like 0.6 kilopascals, compared to Earth's 101.3. A huge difference. And crucially, it found no global magnetic field like Earth has. So those findings together strongly suggested liquid water, which we think is essential for life, just couldn't be stable on the surface today. It looked, frankly, more like the moon than a potential second Earth.
So that definitely cooled expectations a bit, shifted the focus from, complex life or civilizations down to maybe simple microbes, hiding underground perhaps.
Right. But then subsequent missions started to completely change that picture. They revealed a very, very different story about Mars's ancient past.
This is where it gets really interesting.
It really does. Starting around the late 90s with missions like Mars Global Surveyor, and then continuing with the rover's Spirit, Opportunity, Curiosity, Perseverance, our understanding has just been revolutionized. We found absolutely overwhelming evidence of past water activity all across the planet.
Okay, describe some of that evidence. What are we actually seeing on the ground or from orbit that tells us water was there?
Well, our research points to lots of different things. We see features that look, unmistakably like dry riverbeds winding across the landscape.
Like here on Earth.
Exactly like here on Earth. We see ancient lake beds, too, with layered sedimentary deposits. Those layers could only form if there was standing water there for a long time. And there are even features that suggest there might have been, temporary seas or even larger oceans, possibly in the northern plains area.
And it's not just vague hints, right? Some of these geological features are pretty specific matches to water-formed features on Earth.
Oh, absolutely. Our research specifically mentions these incredibly well-preserved fluvial deltas.
Deltas, like where a river meets a lake or sea.
Precisely. And these aren't just simple channels. They're complex networks showing ancient meandering alluvial channels, very similar to what you see near, say, the Eberswald crater on Mars. When geologists study the shapes, the curves of those old river channels, the paleomeander bend topography, it looks surprisingly Earth-like.
How so?
It indicates processes like lateral accretion, where a river builds up its banks over time as it moves side to side. It's very, very similar to how big rivers like the Mississippi behave today.
Mm-hmm.
Seeing that on Mars is, well, it's compelling evidence for sustained water flow.
That's an amazing image. Earth-like rivers flowing on Mars billions of years ago. But wait, for rivers to flow, you need more than just water, right? You need a thicker atmosphere to keep the water from just boiling away instantly in low pressure.
You do. And we have evidence for that thicker atmosphere, too. It comes from analyzing the composition of the thin atmosphere Mars has now, specifically by looking at isotopes.
Isotopes, like different versions of the same element.
Exactly, different weights. So gases in Mars's atmosphere today, like nitrogen, carbon, oxygen, they seem to be depleted in their lighter, stable isotopes compared to Earth.
Okay, so how does that tell us about the past atmosphere?
Okay, think of it like this. Lighter versions, the lighter isotopes of a gas, are easier to lose to space over long periods, especially through processes like photochemical escape, where sunlight breaks down molecules and the lighter bits can escape the planet's weaker gravity more easily.
Right, makes sense.
So, by looking at the ratio of heavier to lighter isotopes that are left today, scientists can kind of work backwards. They can estimate how much of that lighter isotope must have been lost over billions of years.
And what does the nitrogen tell us? You mentioned nitrogen.
Yes, our research points out that while Mars and Earth have roughly similar isotope ratios for carbon and oxygen, the lighter nitrogen isotope nitrogen-14, is much, much more depleted on Mars. Significantly so.
Suggesting a lot was lost.
Exactly. It strongly suggests significant atmospheric loss, likely through that photochemical escape process. Based on that, scientists estimate that the initial amount of nitrogen gas, the N2 pressure, in the ancient Martian atmosphere could have been up to maybe 30 hectopascals.
Okay, how does that compare to today or to Earth?
Well, today Mars is only around 6 hectopascals on average, and Earth is way up at 1013. So 30 is still much thinner than Earth, but it's orders of magnitude denser than Mars's atmosphere is now. Thick enough, potentially, to support liquid water on the surface.
And a thicker atmosphere would also help trap heat, right, making it warmer.
Yes, greenhouse effect. It would have raised temperatures, potentially enough for liquid water to be stable, at least sometimes in some places. So we've got evidence for past water, evidence for a thicker atmosphere. What else do you need for a potentially habitable world, and what went wrong?
Good questions.
Another really critical piece is a protective magnetic field. Earth has one, a global field, generated by the churning molten metal in our outer core. It's called a core dynamo.
And that acts like a shield.
It does. It deflects most of the harmful charged particles streaming out from the sun, the solar wind. Without that shield, the solar wind can basically strip away a planet's atmosphere over time.
So, did early Mars have a magnetic field?
The evidence says yes, it likely did. Our research indicates that while Mars doesn't have a global field anymore, our spacecraft have detected patches of strong magnetism locked into the really ancient crustal rocks, especially in the southern highlands. These rocks formed billions of years ago.
Fossil magnetism.
Exactly. It's like a recording. It's strong evidence that Mars did have an active global dynamo generating a magnetic field way back in its early history.
Okay, and how long did that protection last?
Well, estimates vary a bit, but our research mentions evidence suggesting this early field could have lasted until maybe around 3.9 billion years ago, perhaps even a bit later. So it was active for several hundred million years, maybe longer, during the planet's early wetter period.
So let's recap. Early Mars. Thicker atmosphere, liquid water flowing, protective magnetic field. Sounds pretty promising for habitability, at least for simple life.
For a while, yes. It paints a picture of a very different early Mars.
So what happened? Why did the dynamo shut down? Why did the atmosphere get stripped away?
The leading scientific explanation, the one supported by our research, really comes down to Mars's size. It's much smaller than Earth, only about half the diameter.
Okay.
And smaller rocky planets cool down faster internally than larger ones. So the thinking is that Mars's core cooled relatively quickly, faster than Earth's. And that cooling caused the churning motion, the dynamo, to stop, probably around that 3.9 billion year mark.
The internal engine just died out.
Essentially, yes.
Yeah.
And once that global magnetic shield was gone, the solar wind had direct access to the upper atmosphere.
Oh.
Yeah, those high-energy particles started hitting the atmosphere directly, effectively kind of sandblasting it away over millions and billions of years. That process is called solar wind stripping. Combine that with a decrease in geological activity like volcanism, which normally helps replenish atmospheric gases as the planet cooled overall.
And you get the transformation.
You get the transformation from that potentially warm and wet early world to the cold, thin atmosphered, seemingly dry planet we see today.
Wow. That's quite a dramatic planetary story. So billions of years ago, during what geologists call the Noachian period, Mars was probably a world with liquid water, a more substantial atmosphere, a magnetic field, conditions that seem, well, potentially habitable for microorganisms at least?
That's the prevailing view based on the evidence we have now. The habitability really started to degrade after that, from the mid-Hesperian period onwards. While other things likely played a role, like big asteroid impacts or changes in the planet's tilt over time, the loss of that magnetic field and the subsequent atmospheric stripping seemed to be the critical turning points.
And the surface became much harsher.
Increasingly hostile, yes. Low pressure, extreme cold, much higher levels of surface radiation. As our research points out, if life did arise on early Mars, and if it managed to survive this transition, the subsurface underground became the most likely place for it to hang on.
Okay, so this scientific picture of an early, potentially habitable Mars, it naturally leads us down this incredibly speculative, but let's face it, endlessly fascinating path. The panspermia hypothesis.
Ah, yes. Panspermia.
The idea that life didn't actually start here on Earth, but came from somewhere else. Maybe Mars.
It's a concept that, well, it gained some traction, partly because scientists needed explanations for life's origin, after they definitively disproved spontaneous generation.
Yeah.
The old idea that life could just appear from non-living stuff right now.
Right.
So the main scientific theory today is abiogenesis life arising gradually from complex chemistry right here on early Earth. But panspermia offers this alternative. What if life exists out there already, and it just gets spread around the cosmos, transfer between planets?
And the specific version connecting to Mars is lithopanspermia, right? Life traveling on rocks.
That's the one, lithopanspermia. The idea is that a huge impact on one planet, say Mars, could blast rocks off the surface with enough force to escape the planet's gravity.
Carrying microbes inside.
Potentially, yes. If microbes were present in those rocks, the rock itself could act like a little protective spaceship, shielding them somewhat from the harshness of space, the vacuum, the radiation as they travel. And if that rock eventually landed on another habitable planet, like early Earth,
It could seed that planet with life.
that's the hypothesis. And we know for sure that the building blocks, the complex organic molecules needed for life, can travel through space. Our research highlights that this idea, sometimes called pseudopanspermia, isn't controversial anymore. We find amino acids and other organic stuff in meteorites and interstellar clouds all the time.
So the ingredients can definitely travel. The big leap is whether actual living organisms, even tiny microbes, could survive that whole process. The ejection, the journey through space, the atmospheric entry and impact on a new world.
That is the crucial question. And this is where Mars becomes such an interesting candidate as the potential source of Earth's life.
Why Mars specifically?
Well, a few reasons. First, as we just discussed, we now know early Mars was potentially habitable billions of years ago. Maybe even before life seems to have gotten started here on Earth. The timing could work.
Okay.
Second, we know for a fact that rocks have been blasted off Mars by impacts and have traveled through space and landed right here on Earth. We call them Martian meteorites.
We actually have pieces of Mars here. That's amazing.
We absolutely do. Our research specifically mentions the ALH 84Sal01 meteorite. It was found in Antarctica back in the 80s, and it's considered, an ancient primordial Mars sample.
And this is the one that caused a massive stir in the 90s, right? With claims about fossilized microbes inside it.
That's the one. Exactly. Scientists studying ALH 84,001 found several features, tiny structures that looked a bit like bacteria, certain mineral formations, organic molecules that some interpreted as possible signs of ancient Martian life, fossilized microorganisms.
But it wasn't conclusive.
No. It sparked a huge scientific debate that, in many ways, is still ongoing. The general consensus in the mainstream scientific community is that while those features are intriguing, they aren't definitive proof of life. They're generally considered possible biosignature signs that could be caused by life, but which also have plausible non-biological explanations. Contamination from Earth is also a concern.
So, tantalizing hints, but no smoking gun from that meteorite yet.
Not one that everyone agrees on, no. The evidence remains ambiguous.
Okay, so what about the overall scientific status of panspermia today? Is it seen as a serious contender against abiogenesis?
Our research, including looking at discussions within scientific circles, suggests that while panspermia is seen as an interesting idea, maybe even plausible mechanism, it's not currently considered a very useful scientific hypothesis.
Why not useful?
Well, mainly because it's incredibly difficult to test directly right now. And as somebody going out, it doesn't actually solve the fundamental problem of how life originated in the first place. It just moves the location.
Ah, right. It pushes the problem elsewhere.
Exactly. To really figure out if it happened versus abiogenesis here on Earth, we'd ideally need to find life on Mars or other planets and compare its fundamental biochemistry and genetics to Earth life. See if there's a family resemblance. That's obviously way beyond what we can do currently.
So it's not dismissed, but it's kind of on the scientific back burner because we can't really test it yet.
Pretty much. It's a valid hypothetical way life could spread, but proving it actually did seed Earth from Mars requires evidence we just don't have. Now, this whole discussion about life on Mars, it brings us to another interesting area where scientific data meets, well, more fringe interpretations.
Okay.
While the mainstream search focuses on finding conclusive evidence, ideally bringing back samples, some researchers look at the data we already have, especially from older missions, and argue it's enough.
You mentioned the Viking landers earlier. They had experiments looking for life back in the 70s.
Yes, exactly. Viking had several biology experiments. One in particular, the labeled release experiment, or LR, gave a really intriguing result. It involved adding a nutrient solution tagged with radioactive carbon to a Martian soil sample.
And looking for signs of life eating it.
Essentially, yes. Looking for the release of radioactive gas, which would suggest microbes were metabolizing the nutrients. And the LR experiment did show a positive result. Gas was released.
Wow. So it found life.
Well, here's the catch. Another instrument on Viking, the Gas Chromatograph Mass Spectrometer, or GCMS, was designed to detect organic molecules, the actual building blocks of life as we know it. And it found none, or at least levels so low they were initially attributed to contamination from Earth.
So conflicting results. One experiment says maybe metabolism, the other says no building blocks.
Exactly. And because of that conflict, particularly the lack of detected organics, the official conclusion at the time was that the positive LR result was likely due to some unusual non-biological chemical reaction in the Martian soil, not life.
Okay, that makes sense.
However, our research notes that this interpretation hasn't been universally accepted, especially not by everyone involved. Some scientists, notably Gilbert Levin, who was actually the principal investigator for that LR experiment, along with others like Joseph Miller, Navarro, Giorgio Bianciardi, and Patricia Ann Stratt, they have continued to argue for decades that the Viking LR results were positive. They believe it is sufficient evidence for present-day microbial life on Mars.
Really? Decades later, they're still saying that data showed life.
Yes. They propose that the GCMS might have failed to detect organics for various technical reasons. Maybe the organics were destroyed by the heating process in the instrument, or maybe Martian life just doesn't use the same organics we were looking for. They maintain the LR results stand as evidence for life.
So it's a reinterpretation of that old ambiguous data.
It is. It's a classic case in science where puzzling data from early missions continues to fuel debate and different viewpoints, even if the broader scientific consensus demands much stronger, clearer evidence. But it's important to note, these are scientists arguing for microbial life based on that specific experiment, not, ancient pyramids or anything like that.
Right. Okay, so from microbes, let's take that giant leap now into something that really grabs the public imagination. The whole idea of ancient, maybe even intelligent civilizations having existed on Mars in the distant past.
This is where we move firmly into the realm of speculation, often fueled by our human tendency to see patterns and our fascination with the unknown. Our ability to get these amazing high-resolution images of Mars is fantastic for science, but it also means people scrutinize every rock and shadow looking for anything unusual.
And this is where things like the faceonmars come in, isn't it? Even though our specific research material didn't detail the Cydoniaregion, that's the classic example of this whole phenomenon.
It absolutely is the classic example.
Yeah.
That initial low-resolution Viking image from the 70s showed this landform that, under very specific lighting and shadow conditions, looked uncannily like a human face staring up from the surface.
Spooked a lot of people.
It did. But then later missions, like Mars Global Surveyor and Mars Reconnaissance Orbiter, took much, much higher resolution pictures under different lighting. And those clearly showed it's a natural geological feature, a mesa, that just happens to look like a face from one angle with the right shadows. A trick of light.
Our research did mention a more recent example, though, that Reddit discussion about the doorway image from one of the rovers.
Yes, that's a perfect modern illustration of the same thing. An image came back showing what, to some eyes, looks like a neatly carved rectangular opening, like a doorway cut into a rock face.
And the internet went wild.
Predictably, yes. It immediately sparked online chatter, conspiracy theories, suggestions. It had to be artificial.
But the scientific explanation, what did the discussion threads conclude?
As those very Reddit threads our research mentioned discussed, these kinds of things are almost always examples of pareidolia.
Pareidolia, seeing familiar patterns in random things, like faces in clouds.
Exactly. Our brains are just hardwired to find patterns, especially familiar ones like faces or geometric shapes, even in random or ambiguous data. The doorway has perfectly natural geological explanations. It could be a natural fracture or a joint line in the rock that's eroded differently, or just the way shadows fall in a natural alcove or niche. It looks like a doorway to us because we know what doorways look like, not because someone built it.
It's a really powerful psychological effect. We want to find meaning.
We absolutely do. And while pareidolia explains many of these specific anomalies, the bigger question lingers for some people. Okay, fine, maybe that rock isn't artificial, but what if an ancient civilization did exist? Could we actually find any evidence? What does the science say about the chances of finding ruins after billions of years on Mars?
Let's dig into that from the scientific perspective, based on our research. If you had, say, a civilization roughly comparable to ancient Egypt or Rome, building with stone, maybe some metal, existing way back when Mars was potentially wetter 3 or 4 billion years ago, what are the odds of finding their structures today?
Based on what our research suggests about Martian geology, the odds are incredibly low. Vanishingly small, probably.
Why so low?
Because of the sheer amount of geological processing that's happened over billions of years. Even during that early wetter period, Mars wasn't static. We know there was significant erosion from water. Those rivers carved channels. They filled basins with sediment. They generally worked constantly to wear down surface features. Our research also hints at the possibility of some form of ancient tectonics. Maybe not Earth-style plate tectonics, but certainly crustal movement, deformation, volcanism early on.
And what would all that activity do to buildings or cities?
Any surface structures, even massive ones made of stone, would be subjected to literally billions of years of weathering, erosion by wind and maybe intermittent water or ice, burial by dust and sediment. Our research suggests even materials we think of as durable, like metal, would inevitably rust, corrode, and deteriorate over those timescales in the Martian environment. Ceramics would erode.
Could anything survive?
Maybe fragments. But think about trying to distinguish a billion-year-old chunk of eroded, chemically altered concrete from a naturally formed sedimentary rock called breccia after all that time. It would be incredibly difficult, maybe impossible.
What about stuff getting buried?
That's another huge factor.
Yeah.
If early Mars had significant geological activity, like crustal movement or even just massive volcanic eruptions burying landscapes in lava, or large basins filling up with kilometers of sediment over time, any surface evidence could be buried incredibly deep, potentially even recycled into the planet's mantle if there was any form of subduction early on.
So the planet itself actively erases its history, in a way.
Over geological time, absolutely. It works against the preservation of surface artifacts.
So what's the absolute best case scenario then? Is there any kind of evidence that might theoretically last that long, according to our research?
Well, one discussion our research touched upon got pretty speculative. It suggested maybe the only potential long-lasting evidence might be something hidden below the surface, less affected by erosion. Things like remnants of ancient mining operations, perhaps mined out, or seams, collapsed tunnels.
Okay, that's interesting.
Or even more dramatically, maybe a very thin, globally distributed layer of specific, unusual isotopes that wouldn't occur naturally in abundance. Perhaps left over from some massive planet-altering catastrophe, like a global nuclear conflict was the example given.
Wow, that takes things in a dark direction.
It does. But even finding that kind of subtle trace, that thin layer of isotopes, would be incredibly hard. And crucially, proving it wasn't just some natural geological or atmospheric variation after billions of years would be a monumental challenge. Our research emphasizes that over these vast timescales, geological processes tend to smooth things out, average out anomalies, returning things towards the natural background levels.
So bottom line, while the idea of finding Martian ruins is captivating and drives a lot of the popular interest, the scientific reality presented in our research is that finding definitive, unambiguous proof of an ancient civilization is extremely unlikely. The combination of immense time and active geology is just too powerful.
It's a sobering thought for anyone hoping to find pyramids on Mars, but it reflects the reality of how planets change over billions of years.
Okay, let's shift gears again. Moving from the physical past to the sort of mental or mythological connection humans have with Mars. Let's bring in that realm of myth and even psychic claims, which our research also mentioned. We already talked about Mars's role in ancient mythologies, often tied to war, destruction, transformation because of its color.
Right. And that long history of seeing Mars through a mythological lens is really fundamental to our relationship with the planet. It's been viewed as this powerful force, maybe even influencing things here on Earth. That cultural backdrop, I think, sometimes makes people more open to unconventional ideas about Mars.
And this leads us into some really unusual territory explored in our research.
Yeah.
Things like attempting to use psychic abilities or remote viewing to learn about Mars. You mentioned the CIA's Stargate project earlier.
That's right. And it's not speculation that the government was interested. It's a documented fact. Various parts of the U.S. government, including the Defense Intelligence Agency and later the CIA, did actually fund research into remote viewing for years. The Stargate project was the umbrella name for some of these efforts, basically trying to see if people with alleged psychic abilities could gather useful intelligence information from afar.
And this project was specifically linked to Mars at some point, like that 1984 session mentioned in the intro?
Indeed. That specific 1984 remote viewing session targeting Mars, the one described at the start, describing beings and pyramids and catastrophe, is a very widely discussed, though controversial, example associated with these kinds of programs. Whether the details are accurate is another matter, but sessions like this, making claims about Mars, were part of the project's history and lore.
So the government was basically trying to use psychics to spy on other planets.
Well, to spy on anything remotely, potentially including inaccessible locations like Mars or hidden military sites or whatever intelligence targets they had. They were exploring the possibility. The Stargate project itself was formally transferred to the CIA around 1995, and they commissioned a proper external evaluation to see if it actually worked, if it was worth continuing.
And what did that big review conclude? Did remote viewing prove to be a reliable intelligence tool?
The evaluation results were mixed and ultimately led to the project being shut down. Our research details this. The CIA brought in two main external reviewers. One was Jessica Utz, a statistics professor. She looked purely at the statistics from controlled experiments done over the years and concluded there was a statistically significant effect. People were scoring slightly above chance, maybe 5% to 15% above chance, consistently enough that it likely wasn't just luck.
Statistically significant. That sounds like proof it worked.
In a purely statistical sense, maybe. But statistical significance doesn't automatically equal proof of psychic powers. The other main reviewer, Ray Hyman, a psychologist and well-known skeptic of paranormal claims, argued very strongly against concluding that ESP, or remote viewing, had been proven.
Why? What were his issues?
He pointed to several problems: methodological flaws in some of the experiments, a lack of independent replication of the best results under really strict, foolproof conditions, and critically, the potential for subtle cues or background information to leak to the remote viewers, consciously or unconsciously, influencing their reports. He argued you couldn't definitively rule out those normal explanations for the slightly above-chance results.
So the results weren't clean enough.
Exactly. And maybe even more damning, our research mentions that other reviewers, Mumford, Rose, and Goslin, who looked specifically at how the remote viewing reports were used for actual intelligence operations, found something troubling. They found evidence that sometimes the raw reports from the viewers were apparently altered or interpreted after the fact by project managers to make them seem more accurate, to make them fit known background information better.
Oh, that definitely undermines things.
Hugely. It cast serious doubt on how reliable any of the claimed hits really were, and made it almost impossible to objectively assess the accuracy of the raw psychic information itself.
So what was the final verdict from the CIA?
Based on all this, the methodological concerns, the lack of replication, the questions about data handling, and the recommendation that proving anything would require much more rigorous, expensive research, the CIA terminated the Stargate project in 1995. Their official conclusion, according to our research, was that remote viewing had never provided information that was reliable or specific enough to be used as a basis for actionable intelligence. It just wasn't useful in the real world.
Okay. So while the idea of getting psychic insights into Mars, or those dramatic claims from the 1984 session about a dying world and fleeing inhabitants, while those ideas are compelling and maybe resonate with those ancient myths of transformation and catastrophe, the actual scientific evaluation commissioned by the government found no reliable evidence that these methods work.
That's the crucial takeaway from the Stargate evaluation described in our research, yes. Science hasn't validated these claims as a way of knowing things about Mars. But, the fact that these attempts were even made, that people turned to such unconventional methods, it really speaks volumes about how deep the mystery of Mars runs for us, how strong that desire is to understand it by any means necessary.
The unknown keeps calling.
Exactly. The enduring myths, the scientific unknowns, they continue to fuel these speculative ideas about lost worlds, planetary transformation, things that echo those ancient archetypes.
Okay, from psychic speculation, let's turn back towards the future, towards concrete plans. Because despite all the challenges, all the mysteries we still haven't solved, there is this massive, renewed push happening right now to actually send humans to Mars.
Oh, absolutely. It really feels like a new space race is heating up, doesn't it? But this time, it's not just governments. You've got private companies, visionary individuals pouring huge amounts of resources and ambition into making Mars happen.
And the most visible figure there has to be Elon Musk, right? With SpaceX and his incredibly bold goal of not just visiting, but establishing a large, self-sustaining colony on Mars, talking about potentially 80,000 people or more eventually.
He's definitely pushing the envelope.
Yeah.
And he's very upfront about the risks. Our research mentions him calling it a dangerous delusion, but also a glorious, life-threatening adventure. That's quite the sales pitch.
It is. But he's not alone in this renewed focus. Our research also mentions other prominent figures who've expressed strong interest or advocated for Mars colonization, people like Richard Branson, and notably Buzz Aldrin, the second man on the moon, who has been arguing for decades that Mars should be humanity's next giant leap. And Jeff Bezos with his broader vision for moving industry and people off Earth.
It really feels like we're at a point where those science fiction dreams of living on Mars are starting to morph into actual engineering challenges, budget discussions, and serious logistical planning.
It does. What about the traditional space agencies like NASA? What are their official plans?
NASA has very detailed, long-term strategic plans. Our research outlines their Mars Exploration Program 2024-2044 plan. It's built around three main co-equal goals, or themes.
Okay, what are they?
First, keep exploring the potential for Martian life, past or present. Second, directly support future human exploration, figure out the resources, the hazards, the technologies needed. And third, understand Mars as a dynamic planetary system, how it works today, how it evolved over time.
And a really big part of that, especially the life question, is bringing pieces of Mars back here, right? Mars sample return.
Exactly. That's a cornerstone initiative. The Perseverance rover is collecting samples right now, sealing them in tubes. The plan, though complex and facing budget reviews, is to launch a future mission, probably in the early 2030s, to retrieve those samples and bring them back to Earth.
Why is that so important?
Because scientists back here can analyze those samples with instruments far more powerful and sophisticated than anything we can realistically send to Mars on a rover. Studying pristine Martian rocks in soil and Earth labs could absolutely revolutionize our understanding of the planet's history, its geology, its climate, and crucially, whether it ever hosted life.
Beyond sample return, what's NASA's general approach for future robotic missions? Are they still sending big flagship rovers?
The push now, according to our research, is also towards making exploration more affordable and more frequent. They want a strategy that allows for lower-cost missions, sent more often, to explore a wider variety of locations on Mars and to be able to react more quickly if a rover finds something really interesting.
So maybe more smaller, focused missions.
That seems to be part of the thinking, yes. Maybe selecting multiple smaller missions that could launch together, maximizing the science return for the cost. It's about building this sustainable, ongoing robotic presence that keeps learning and prepares the way for humans.
But actually getting humans there and keeping them alive, that's a whole different ballgame, isn't it? The challenges must be immense.
Monumental is probably the right word. Our research highlights some of the biggest hurdles. Radiation is a huge one.
Because Mars doesn't have that global magnetic shield anymore.
Right, and it has a very thin atmosphere.
Yeah.
So astronauts traveling to Mars, and especially living on the surface, would be exposed to much higher levels of galactic cosmic rays and energetic particles from the sun. Our research notes that unprotected life on the surface would receive lethal doses fairly quickly. Even microbes don't survive long near the surface.
So how do you protect people?
You need incredibly effective shielding on the spacecraft, for the months-long journey, and in the habitats on Mars. That means heavy materials, or maybe building habitats underground or covering them with thick layers of Martian soil, regolith. Or maybe developing entirely new technologies like active magnetic or plasma shields. But those are still very much in the research phase.
And beyond radiation, just the environment itself
is incredibly hostile. Our research mentioned President Obama's stark comparison, potentially more inhospitable than Earth after a nuclear war. You've got near-vacuum atmospheric pressure, extreme temperature swings, toxic chemicals like perchlorates in the soil.
So habitats need to be perfect seals.
Absolutely. They need to provide complete environmental protection. And crucially, for any long-term stay or colonization, astronauts will need to live off the land as much as possible, using what's called in situ resource utilization, or ISRU.
Using Martian resources, like the ice we know is there.
Exactly. Extracting water from ice deposits is key. You can use it for drinking, obviously, but also split it into oxygen for breathing and hydrogen for rocket fuel. Using Martian soil or rock for construction materials, for 3D printing habitats or radiation shielding. Maybe even eventually developing ways to grow food in Martian greenhouses using processed soil and local water.
That sounds like the only way it could be sustainable long-term.
It really is. Relying solely on supplies launched all the way from Earth would be astronomically expensive and logistically impossible for a real colony. ISRU is critical.
So the future of Mars exploration is this amazing mix of cutting-edge science to understand the planet, incredibly daring engineering to get people there and keep them safe, and then this almost pioneering ingenuity to figure out how to live there. It's a huge undertaking.
It truly is a testament to human ambition and curiosity. And, it's a profound thought that maybe our drive isn't just about pure discovery, but might have echoes of something else, some deeper planetary connection we don't fully understand.
Okay, before we wrap things up, there's one more ongoing scientific puzzle on Mars we should touch on. Something that keeps scientists debating and points towards the possibility of current activity, the mystery of methane in the atmosphere.
Ah, yes, the Martian methane puzzle. It's a really fascinating one. Over the last couple of decades, various spacecraft orbiting Mars and even some powerful telescopes here on Earth have detected trace amounts of methane gas in Mars's thin atmosphere.
Okay, trace amounts. Why is that a big deal?
Because methane is potentially a biomarker. On Earth, most of the methane in our atmosphere comes from two main sources: geological activity, like volcanism or certain water rock reactions called serpentinization, or biological activity. Specifically, microorganisms called methanogens produce methane as a waste product. They're common in places without oxygen, like swamps or animal digestive tracts.
So finding methane on Mars could mean either ongoing geology or ongoing life.
Exactly. That's why it's so exciting and so frustrating. Adding to the puzzle is the fact that methane shouldn't last very long in Mars's atmosphere. Sunlight, the UV radiation, breaks it down through photochemical reactions relatively quickly. Its atmospheric lifetime is maybe only a few hundred years.
So if we're detecting it now,
it strongly suggests there must be some kind of active source replenishing it today, or very recently. It can't just be leftover gas from billions of years ago. There has to be something producing it or releasing it now.
But the detections have been inconsistent, you said.
Highly inconsistent. That's the really weird part. Some instruments detect it, others in the same area don't. Levels seem to spike and disappear. They vary with the seasons in some locations. Our research notes that currently, the only place it's been consistently detected, albeit at very low levels and with seasonal variation, is Gale Crater, where the Curiosity rover is operating.
Only there. That's strange.
It adds another layer of mystery. Is the source very localized, maybe underground seeps that only release gas occasionally? Is it related to some specific geology only found in Gale Crater? Or is Curiosity just in the right place at the right time? We don't know.
It's like a classic scientific whodunit, playing out light years away, a tantalizing clue that could point to either geology or biology, but we just don't have the definitive answer yet.
Precisely. It's one of the many active mysteries Mars still holds. And our research touched on others too, like understanding the huge difference between the smooth, low-lying northern hemisphere and the ancient, heavily cratered southern highlands, or deciphering the full history of asteroid impacts and how they've shaped the planet. Mars is still very much a dynamic, evolving world with many secrets left to uncover.
So we've really journeyed through the many faces of Mars in this episode, haven't we? From the way ancient humans saw gods in its red glow to the scientific discovery of its wetter past.
This speculative but intriguing ideas about life perhaps traveling between Mars and Earth.
The immense challenge of finding any evidence of hypothetical ancient civilizations.
Even the strange history of trying to probe its secrets through unconventional means like remote viewing.
And now, the very real ambitious plans to send humans there in the near future. Through it all, Mars remains this world steeped in profound mystery.
It truly does. And the implications if we solve some of these mysteries are just enormous. As our research points out, finding definitive evidence of Martian life, even simple microbial life, past or present, would be revolutionary. It would tell us instantly that life isn't just a fluke that happened here on Earth. It would suggest life might be common throughout the universe.
And going back to panspermia, if we ever found proof that life did originate on Mars and seed Earth, what would that do to our sense of self, our identity? Would we have to rethink what it means to be an Earthling if our deepest roots are actually Martian?
It would fundamentally redefine our place in the cosmos, wouldn't it?
Yeah.
Add an entirely unexpected chapter to the human story and the story of life itself.
And maybe that's the heart of it. Maybe that's the deep underlying reason for our enduring, almost gravitational pull towards Mars. It seems to call to us in a way that feels different, more intense than just scientific curiosity or the desire to plant a flag.
It's certainly possible. The mystery of its lost potential, the tantalizing hints of water and maybe life, the way it mirrors Earth's past in some ways. It resonates deeply.
So, as we stand on the brink, preparing to send humans across space to walk on that red soil, are we simply embarking on a journey of pure discovery, exploring an alien world entirely separate from us?
Or is there maybe an unconscious echo at play, a feeling perhaps not just of going, but of returning? Could there be some kind of planetary memory buried incredibly deep within our collective story, calling us back home to a place where life, maybe even our kind of life, might have first flickered into existence?
It's a thought that really bridges that gap, doesn't it, between the ancient myths and the future rockets. A layer of almost mythic possibility woven into the incredible scientific journey ahead.
A journey of discovery? Or maybe remembering. It adds a whole other dimension to why we look up at Mars and feel that pull.
That's it for this journey beyond the known. If the unknown calls to you, don't forget to like, subscribe, and follow. There's so much more waiting to be discovered.